Hello fellow space enthusiasts. We all know what happened to Apollo 13, don't we?
We just lost the moon.
But what would have happened if the original crew of James Lovell, Thomas Ken Mattingly and Fred Haise had completed their intended mission?
This is Houston. Say again, please?
Let's go through what the third lunar landing would have looked like if the crew swap and the event at 55 hours into the flight had not occurred. Before we start, don't forget to hit the subscribe button if you want to see more Apollo videos like this. The 70s had landed, and NASA switched its focus from the attention-grabbing test flights of the late 60s to a more scientific approach, aimed at revealing the mysteries that existed around the moon's formation and subsequent geological activity. The selection of Lovell and Haise as the surface team for Apollo 13 had filled the geologists with optimism. If any further proof was needed that this crew was dedicated to scientific discovery, it could be seen in the Latin phrase emblazoned across their mission patch, Ex Luna Scientia, from the moon knowledge. The massive Saturn V moon rocket carrying the crew of Apollo 13 left Pad 39A at the Kennedy Space Center at 2:13 p.m. Eastern Standard Time on the 11th of April 1970.
4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. The Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
Achieving orbit, Lovell, who had already been into space on 3 previous missions, remarked,
"Roger, Houston, and it looks good to be up here again."
Following the docking with the lunar module, Apollo 13 was sent on its way towards the moon. Everything about this mission was geared up to gathering scientific data. Even their discarded S-4B rocket stage was going to be used to obtain seismic measurements by sending it on a collision course with the moon. The normal translunar coast activities took place, including Lovell and Haise entering the lunar module to check it out. Viewing Comet Bennett through the sextant was tried on the way out to the moon, but the viewing conditions were not ideal. One celestial body that the crew had no trouble in seeing was the moon. Looking out of the window, they could see it growing larger. It was all systems go. So far so good. From this point on, I am going to use film and photos to depict what would have happened during the alternate scenario of a successful mission. After a 77-hour long journey, Apollo 13 would have swung into lunar orbit on the 14th of April, and the crew would have gotten their first close-up look of the moon's far side. Haise would say of this view, "When we came up on the backside terminator, the colour I saw was a combination black to a reddish brown to white mantling on some of those features." The following day, Lovell and Haise would have been ready to land on the moon. When it came time to undocking, the 2 spacecraft would be in an orbit that at its lowest point would be around 9 miles above the surface. This would mean that the lunar module wouldn't need to perform any descent orbit insertion burns. As a result of this, Lovell would have had extra fuel for the descent phase, which was important because of what he was aiming to do during the approach to the landing site. With a go to proceed, the lunar module Aquarius would have been ready for powered descent initiation at a ground elapsed time of 103 hours and 31 minutes. Lovell and Haise were aiming to land in an area north of the crater Frau-Moreau, called the Frau-Moreau Islands. Although pinpoint landings were now a feature of the missions, Apollo 13 was aimed for a much more uneven area, so Lovell was given some leeway regarding his touchdown point. He was aiming to set Aquarius down as short as he could to reduce the distance to Cone Crater's rim. The extra fuel would give Lovell more hover time to help him achieve this. If all went well during the descent, touchdown would have occurred at 9:55 p.m. Eastern Standard Time on the 15th of April. Just a couple of hours later, the hatch would have been opened and Lovell would have exited Aquarius and climbed down the 9 rungs of the ladder to start the first period of surface activity. For Lovell, this moment had been much anticipated. After Apollo 8, he had been determined to return and cross the last 70 miles from lunar orbit to the surface. Lunar surface lighting conditions and not TV schedules dictated when the crew landed on the moon, and so despite interest for the moon landings waning, Lovell would have stepped onto the moon at the distinctly TV audience unfriendly time of 2:29 a.m. Eastern Standard Time on the 16th of April. With one hand holding onto the ladder, he would have put out his boot and stepped onto the moon saying something appropriately historic, such as, "We hope the knowledge we bring from the moon will help mankind to live in greater peace on the earth." Turning his attention to his mobility, Lovell would have noted that he had no trouble in moving around. Lovell would then have received the two lunar surface 70mm Hasselblad cameras, attaching one to the front of his remote control unit. After a few minutes he would have left the shadow of Aquarius and started to collect a small contingency sample in case an emergency forced the cancellation of the moonwalk. About 15 minutes after Lovell had taken his first steps on the moon and become the 5th man on the moon, Hayes would have joined him on the surface, making him the 6th man on the moon. While Hayes tested his footing, Lovell would have unstowed and deployed the large S-band antenna for voice relay, television coverage and lunar module telemetry to the Earth. Collecting the TV camera, Hayes would have placed it about 50 feet away from Aquarius. At this point, Hayes would have climbed back into the ascent stage to switch over to the deployed S-band antenna. Lovell would have passed up the spare lithium hydroxide canisters and PLIS batteries for later use, and the contingency sample via the lunar equipment conveyor. After checking that the signal had been acquired by mission control, Hayes would have rejoined his commander on the surface. With the colour TV showing the earthbound audience the lunar surface activities, it would have been easier to distinguish between the two astronauts, because the commander's spacesuit now had red stripes around the knees, just above the elbows, and on top of the lunar extravehicular visor assembly. There was also an extra addition to Lovell's visor. The backup crew had affixed a blue naval anchor, something that had surprised Lovell when he had seen it during the TV broadcast on the way to the moon.
Okay, Jack, who's picking up my lever?
It would now have been time for Lovell and Hayes to deploy the US flag carried aboard in the Mesa, before taking the customary photos beside the stars and stripes on the lunar surface. Lovell would then have repositioned the TV camera to view the equipment bay, and after both men had inspected and photographed the lunar module, they would have prepared for the main objective of this first moonwalk. The LSAP would have been attached to a carrying bar, sample return container number 1 and the lunar drill unstowed, and the radioisotope thermoelectric generator would have been fueled. As on Apollo 12, the crew would have transported their geology tools on a hand tool carrier. There was no modular equipment transporter on this mission. Lovell would then have aimed the TV camera down sun in the direction they would be working in, and then the two men would have begun their walk to find a suitable LSAP deployment site, approximately 500 feet away from Aquarius. After selecting a relatively level location, the two men would have gone to work. While Lovell was busy deploying the nuclear-powered scientific station, Hayes would have set about a task that he had been looking forward to: drilling on the moon. After assembling the lunar drill for the heat flow experiment, he would have drilled two 10-foot holes to place the heat flow probes in. After this, Hayes, with the help of Lovell, would have used the drill to collect a deep core sample. After photographs had been taken of the deployed experiments and the central station had been checked to make sure it was positioned correctly, they would have begun their first geological traverse. Depending on the time remaining, they would have headed west looking for the rim of Star Crater. The distance they could walk from Aquarius was dictated by the 45-minute supply of emergency oxygen they had in their oxygen purge system. On their return walk, they would have walked around doublet craters. As they walked along the undulating terrain around their landing site, they would have reported back their observations, stopping from time to time to conduct documented collections of samples with descriptions and photographs. After arriving back at Aquarius, Hayes would have deployed the solar wind composition experiment. The collected samples would have been placed into sample return container number 1 and readied for transfer into the ascent stage, and sample return container number 2 would have been unstowed. Then it would have been time to finish the first moonwalk and climb back into Aquarius after spending around 4 hours and 42 minutes on the surface. As they rested inside the cockpit of Aquarius, they could have taken in the view out of the windows over dinner before closing out the day and going to sleep. A good night's sleep would have been preferable because the next period of exploration promised to be a hard slog uphill. At 10:11 p.m. Eastern Standard Time on the 16th of April, Lovell would have once again descended the ladder into the brilliant sunlight and begun the second period of surface activity at a ground elapsed time of 127 hours and 58 minutes. This moonwalk would have been dedicated to geology in the hope of unlocking some of the secrets of the moon. With the tool carrier loaded, and after a few moments spent repositioning the TV camera, the two men would have set off across the surface. This time the surface team would have headed into the sun towards the base of the crater, towering above them in the distance. Briefly stopping for a trench sample and a second core sample, they would have begun their ascent of the crater, noting that the soil layer was getting deeper, causing their boots to sink into it. It was going to be hard work reaching the summit, not only because it was strenuous walking uphill while wearing bulky spacesuits, but because micro-navigating was going to be challenging. Although they had maps, locating specific surface features was not going to be easy, but Lovell had set Aquarius down within walking distance of the crater, and due to their interest in the geology of the mission, they were in a good position to reach the rim. As they started to climb, they would have soon come across the old mountaineering dilemma of thinking the next rise would be the summit, only to reach it and be faced with yet another rise. Taking a moment to catch their breath, they would have studied their lunar surface maps, looked around their location and conferred with mission control. Luckily, the two men had both been through the rotation on a backup crew and had therefore devoted more of their training for Apollo 13 to geology. Studying the map in relation to their local terrain, Hayes would have pointed in the direction they needed to go. Continuing upwards, the ground would have levelled off as they walked onwards through a field of rocks until the far rim of Cone Crater would have suddenly come into view. Walking on a few more feet, the impressive pit of the crater would have loomed before them, and they would have known that they had reached their target. The near rim was higher than the far rim, so only by being right on top of it could they have found it. It would have also been a surprise to discover that this was not the highest part of the crater. A lesser dedicated crew to the science might have been fooled into heading away from the rim and up to the high point. With time always at a premium on the moon, the two men would have begun the important work of carefully documenting the site. Taking panoramic images and carefully documenting their sampling, they would have used a hammer to chip away at larger rocks, while all the while describing their work to the ground. It would have been a tremendous site to perform geology at. Standing amongst the boulders around the rim, they would have taken in the view from their high vantage point, and there, far off in the distance, across the sun-scorched surface, they would have seen Aquarius. After one final panoramic sequence, it would have been time to begin their walk back, knowing that another major task had been accomplished. Just before they set off, Hayes would have performed one final act in the best traditions of all geology field trips. Choosing a large rock, he would have pushed it with his boot down into the crater, sending it rolling to the bottom. Walking back downhill, the two explorers would have continued their sampling and documenting. Back at the lunar module, the two men would have begun their closeout duties. While Hayes retrieved the solar wind composition experiment, Lovell would have collected the final few samples for return. At the end of their second moonwalk, Lovell and Hayes would have unveiled the plaque on the front landing leg of Aquarius to bring to a close their surface activities after a total of about 4 hours and 43 minutes outside. On the 17th of April at 7:22 am, at a ground elapsed time of 137 hours and 9 minutes, Aquarius would have bid farewell to Fomalhaut after a total stay of 33 hours and 27 minutes. They would be bringing back into orbit with them 95 pounds of lunar samples. Just over 3.5 hours later, Aquarius would have docked with Odyssey, and the two moonwalkers would have been greeted by Mattingly, who would have been busy in lunar orbit carrying out a comprehensive photographic program that included capturing images of potential Apollo landing sites. The crew would have hustled to transfer everything from the lunar module into the command module, and just 2 hours and 20 minutes later, Aquarius would have been jettisoned and sent on its way to impact with the moon. After a total of just over 90 hours in lunar orbit, the crew would have ignited their SPS engine and started their journey home at 1:42 p.m. on the 18th of April. With the successful re-entry behind them, Odyssey would have splashed down in the Pacific Ocean at 3:17 p.m. Eastern Standard Time on the 21st of April, following a mission lasting just over 10 days. As they floated on the ocean, Lovell would have turned to his fellow explorers and said, "Fellows, we're home." Ahead would have been a 21-day period of quarantine in the LRL at Houston, and the beginning of the unlocking of the mysteries of Fomalhaut. And that's what would have happened if the original crew of Lovell, Mattingly and Hayes had flown their intended mission. Of course, in reality, the Apollo 13 mission entered a life and death drama following the failure of one of the oxygen tanks, and were unable to accomplish their landing. But for 55 hours in April 1970, all systems would go for a landing at Fomalhaut.